Welcome to FAULHABER Drive Time. In this video I will show you how to read the performance diagram of a linear actuator out of the L series. The performance diagram could be found on the product page on our website. Here, under characteristic curves, you see the same curve as on the datasheet itself. Let's have a closer look on it. On the x-axis we see the continuous axial output force F in Newton. On the y-axis, the maximum permissible continuous output speed v in millimeter per second, both in logarithmic scale. The different blue areas are the recommended operation areas in continuous operation for the different stages. The higher the reduction ratio, the higher the output force and the lower the speed. These values are recommendations to obtain maximum lifetime. The gray areas with the dashed lines are the peak output speed and the peak axial force for intermittent operation and are higher as the blue ones. Do not forget that we are in a logarithmic scale, so the intermittent operating area is nearly the double as the continuous operation. These values could be achieved for short intervals, not exceeding 20% of the duty cycle. The maximum output speed depends on the maximum achievable speed of the gearhead. The maximum output force depends on the maximum gearbox torque. So the output power is resulting out of these two values. For the next two lines, it is relevant to understand the support method in your application. We consider the most two used in our datasheets. In your adapter we have a radial and an axial bearing and created like this a fixed bearing. Here. Therefore the support method depends on the fixing of the second side. This is the fixed single support. You could use it, for example, the option with the tip on the screw to mount a bearing at the end. Like this, it provides a radial support for the screw, but the thermal expansion of the shaft is still possible. This solution is ideal for longer screw length. The other method is the fixed free support, where the end of the screw is not supported. The mounting here is much simpler, but it is only recommended for applications with shorter screw length and slower speed. The red lines show the critical speed for standard screw length with standard nut, the thicker line for fixed single and the thinner line for fixed free support. The vertical blue line refers to the buckling force, also here for the standard screw length and the standard nut, for fixed single and fixed free support. To make it more easy to read it, we wrote the values next to the graphic. What is this critical rotational speed? It is reached when the rotational frequency of the screw equals its first natural frequency, thus causing resonant vibrations. For standard screw length, it is the red line in the performance diagram. For other length, it could be calculated with this formula. You can see that NRC depends on the screw support via the factor K and the screw geometry, so the diameter and the hub length. The shorter and thicker the screw, the higher is the critical speed. Fixed single allows higher speed as the fixed free support. The safety factor S takes other influences into account, such as alignment and final mounting. The critical speed should not be reached in any case. It could damage the system. And what is the buckling force? It is the maximum external compressive force which can deform and eventually break the screw. For standard screw length, and you see the blue line in the diagram. For other length, it could be calculated with this formula. You can see that it depends also on the screw support via the factor K and the screw geometry, also the diameter and the maximum hub length. The longer and thinner the screw, the lower is the buckling force. With fixed single mounting, it is higher as with fixed free. Also here a safety factor is considered. This force should not be exceeded in any case. It will definitely damage the system. As we already talked about the screw support, let me say a few additional words about it. Please avoid hyperstatic mounting of the screw. This could happen, for example, in a fixed single mounting if you link the nut to a linear guide. This system will be stiff and limit vibrations. Additionally, the friction and therefore the current consumption will be higher. With a linear guide, it could be recommended to use the fixed free support. In case of questions, do not hesitate to ask us. Let's summarize. In the performance diagram, we can see the recommended speed and force for continuous operation, as well as the peak speed and force for intermittent operation. We found the buckling force and the critical speed for standard screw length, which must not be exceeded. Thank you for watching this video. Subscribe to our channel and check out our other videos on FAULHABER Drive Time. Feel free to leave a comment down below. Take care and goodbye.